Hi, welcome back to MOG Economics YouTube channel. Hope you guys are doing very okay today. In today's lesson, we'll be continuing with our discussion on game theory. I don't even know when I'm going to make the last class on game theory because new things keep coming up, right? And of course, we're up to the task, so we keep studying, keep learning to help you guys understand economics better. All right, so game theory is basically the analysis of strategic behavior between all the parties involved, right? And the reason why there is strategic in the definition is basically because there is interdependence, right? So in the sense that when a player wants to move, like he has to consider what other players to do, right? So when the players involved are companies, right, in a particular industry, so before Nike does something, it has to think about what Adidas is going to do or what Adidas will do after Nike has taken a decision. So because it has to do with interdependence, of decision making about maybe price, maybe choice of advertisements, or maybe choice to even advertise, or maybe develop a product and on like that. So that's why we call it the analysis of strategic, behavior. But we've discussed these things, this introductory aspects in classes before this. So here we just want to talk about games involving multiple strategies, right? All the ones that I've been doing before now are games involving two strategies, right? So, but here we're looking at multiple strategies, and of course, we've done a couple of classes: Prisoner's Dilemma. We've done this tree. You have normal form game. You have the sequential game. That tree game or whatever. So you could check out our classes if you've not gone through those particular lessons before this particular one. But then that's fine. So there are some concepts I want us to like a few concepts actually that I want us to like discuss before we start what we're doing. Now we have something that we call the strictly dominant strategy. So this is the strategy that gives a player the best payoff among his own choice of strategies, regardless of what the other player does. Right? So the strategy that gives a player the best payoffs, right, among his own choice of strategies, regardless of whatever strategy that the other player, decides to use. Now, we also have what we call the weakly dominant strategy. All right, so it's a strategy that for some of the decisions that the other player is going to make, the strategy is as good as what other strategies will give him, and better than the payoffs of other strategies of that he or she has. Now, I know that can be kind of confusing, but let me like make it easy to explain. So, if a player has let's say he has three strategies, for example. So, if for okay, let me just do something. So, let's say you have strategy A, B, C. Now, A will give you a payoff of 10, let's say 10, you have 20, and then you have 30. And that's the payoff of that 10, that strategy A will give you, regardless of what the other guy is doing. And your strategy B would give you 15, um, 20, and 40. All right. So, what we are saying is that strategy B here is a weak dominant strategy. And why is it a weak dominant strategy? Like for some of the payoffs, like it is better than strategy A, right? But then it is not entirely better than strategy A. So 15 is better than 10, 40 is better than 30, but 20 is just as good as 20. So this is a weak dominant strategy. So that's what I was trying to say that the opponent, when the opponent is playing, right, all of these payoffs are going to have corresponding numbers for the other player. So this could be like 30 for this player, comma 25, comma 10, comma -5, comma 0, comma 50, or whatever. So we are saying that a big dominant strategy is a strategy whose payoff is at least as good as the strategy of as is at least as good as the payoff of a different strategy, at least as good as it. So it is for some part of it, it is as good as it is, and for some parts of the other strategy, it is better than what is obtainable. Right. So if there's a way that you could coin that definition properly for your own sake, but at least you get what I'm trying to say. So let's look at this particular game, and then first we need to find out the dominant strategies before we begin to solve the game. So, do these players have dominant strategies? And I've decided to write them in two inks so that it can be easily understood. Now, you see, the game is between Rebecca and Ini. These are two of my 3 level students like right now. So, I want them to see their names in a particular lesson. Now, the first payoff belongs to Ini. Whoever is on this side is the owner of the first payoff. So 40, 90, 255, whatever, they all belong to Ini. And then for Rebecca, right? So Rebecca's payoffs are the ones in red, right? So anybody that is here, the second payoff belongs to the person. So any like every time, okay. So Rebecca is the owner of all of these payoffs, all the ones in red, all the ones in red, all the ones in red. So let's compare. For Ini has if Ini chooses, then each of them has four strategies to pick. One, two, three, four. Like in the textbook, like because textbook that I got this from is and the shorter textbook, intermediate microeconomics. So you are going to see one, two, three, four, one, two, three, four. But it can get confusing. Like what is one, two, three, four? What is one, two, three, four? And then you now put numbers inside. So I decided to put S in front of it to tell you that they all represent four different strategies. So Ini can embark on strategy one, she will employ strategy two, on and on like that. Rebecca can do the same. All right. So if Ini decides to choose strategy one, no matter what Rebecca is doing, so Ini is going to get a set of payoffs. So she can get 40, 90, 255, right? Then if Ini is playing strategy two, it doesn't matter what Rebecca is playing. Whether if Ini is playing strategy two and Rebecca is playing strategy one, so this is where they're going to land. Ini will be getting 30. Now if Ini is playing strategy two and Rebecca is playing strategy two as well, this is where they're going to land. So whatever Rebecca is doing anyway, whenever you need to use strategy two, these are the different payouts that you can get. So the exact number then depends on what Rebecca is going to do at the end of the day. So if it's strategy three, the same thing. So on and on. This is the way you consider the one for any. Now for Rebecca, our own payouts are arranged vertically. So she can choose strategy one. If she chooses strategy one, right, she can get the set of payouts 20, 25, 55, 98. Then strategy two, she can get the same too. So our own is this way, while in his own is horizontal. All right. So let's. Does any one of them have a dominant strategy? Now, how do we get to that? So normally I'm supposed to like rewrite the whole thing, or should I? So for Ini is going to be comparing the old strategy one against strategy two, against strategy three, against strategy four to see if she has a dominant strategy. All right. Let me just write the pairs for Ini. So only Ini, I have 40, 90, 255, 30, 85, 100, 10, then 38, 22, 75, 85, 44, 155, 40, and 33. So how would you know? Because these are strategies now. One, two, three, and four. Which one is the dominant one? That is the one that is better than every other strategy. So let's see. What's the highest number here? The highest number is 40. So 40 is better than all of these. Okay, so let's see 40. Then what's the highest number here? 90. The highest number here, 200. The highest number here, 55. So that's it. So that means strategy one is strictly better than any other strategy in this particular, among this set of strategies based on their payoffs. So for Ini's strictly dominant strategy is strategy one. You need strictly dominant strategy one because it gives her the maximum payoff among our own different sets of strategies. So for Ini, we're choosing strategy one. Now for Rebecca, remember I said Rebecca's one is arranged this way. So Rebecca is S1, then 2, 3, and then 4. What are the payoffs? 20, let me write it in. Okay, well, no problem. 20, 25, 55, 98, then 300, 55, 65, and then 200, followed by 100, 50, 60. Yeah, I like the way you're following me. That's good. 22, 10, 60, 1. So I was a little bit faster than you are. Okay, it's okay. All right, so look at this. Strategy one is all of this pay off, all of this pay off, all of this pay off. How do we get a dominant one? Just look at where the highest number is for each strategy. Okay. If initially strategy one, these are the payoffs. Strategy two, the highest here, you have 300. So 300, because how will you be comparing in this one? You are comparing this strategy against one that is here. So for strategy two, 300 is better than 20, 300 is better than 100, better than 22. Okay. So let's check again. 55 is better than this, better than this, better than this. Okay, pick 55. Then 65 is better than this, than this, than this. Pick 65. 200 is better than 9. Oh, 105 is close, but at least. All right. So for Rebecca, our own dominant strategy is this guy. So it is better for her to play strategy 2 because it's going to give her the best payoff, right, among all the payoffs of our alternative strategies. And then for this person, we said he picks this. So where's the Nash equilibrium going to occur? Well, the Nash equilibrium is going to occur where the dominant strategies are coinciding. So that's just the way it's going to work, right? Since they each have a dominant strategy, that's what they would definitely play. Like, why should you play something that is not a dominant strategy? You have a strategy that is a strictly dominant strategy, not just anyhow dominant, not a big dominant strategy. So that's the strategy we always play. So the both of them will always play their dominant strategies. And if they do that, so that means in it we play strategy one all the time, right? Because that gives her the best payoff. So it is going to play strategy one. And then Rebecca will play strategy two because that is a dominant strategy. Strategy two is what she's going to play. So we are there coinciding 90 and 300. So the Nash equilibrium is 90 and 300. So where Ine is playing strategy one and Rebecca is playing strategy two. Like it's as simple as that. So you could be asked, is this a pure equilibrium? Yes, it's a pure equilibrium because you don't have more than one Nash equilibrium, right? So if you add like two or more, then that would not be pure. That means different strategies can give you can the players are not kind of consistent. Like you're going to have more than one Nash equilibrium when at least one of the players doesn't have a dominant strategy. So like you're not consistent in your strategies. Okay, it's all depends on what the other guy does. So if he moves this way, I'll pick that strategy. If he moves this way, I'll pick the other strategy. But in this case, this is a pure strategy because the result is definite, right? Just one Nash equilibrium. So you are sure that player one will always play strategy one and player two will always play strategy two. It's a pure equilibrium. So sometimes the instead of you to be asked that um what's the dominant strategy of social person, you could be asked that what is the best response. Now the best response is also like kind of asking you about the dominant strategy that a player should play. Right. So if player two plays strategy two, what's the best response for player one? So player one looks at a set of strategies, which one is going to give me the best payoff. So strategy one, finish. Right, so I'm just trying to tell you this because questions can come in different ways. And we've also established the fact that the Nash equilibrium here is the strategies are strictly dominant strategies because they are better than every other strategy in terms of their payoffs, every other alternative strategies for each of the players. All right, and then another question that you might be asked is this a dominant strategy equilibrium? Yes, of course, because the payoffs at the end of the day resulted from where both players each played their respective dominant strategies. So this is settled. So I want us to go into a different game where there might be no dominant strategy. So how do we solve that kind of problem? So yeah, we're going to analyze this game. There are two players. I changed their names. Normally the head boy and head girl. So that's what is there. But I've changed it to Timmy Tucker and Soliat. Also, two of my students. All right, so for Temitope, he has four set of strategies: A1, A2, A3, and A4. Then Sulias has three alternative strategies that you could use, which is B1, B2, and B3. So again, I've arranged it in a way that is going to be easier for you to identify. The first payoffs belongs to whoever is here. A second payoff in any matrix belongs to whoever is on this part. So, of course, we have to solve this game. So, number one, the question is find the best response for each of the players. So find the best response for each of the players. So what is it asking you to do? Find the dominant strategies. So there are games that you may not even have dominant strategies. So let's see. For Timitope, all right. So we are going to be having is payoffs one, two, one, one. You have two, two, one, three, and you have one, two, three, two. So this is the first example that we did. They had equal number of strategies, the two players, but here one has four strategies, the other one has three. So it's possible, right? So it's not a must that they must have the same number of strategies. So for Timitalk, we are comparing. This is his own A1, A2, A3, and A4. So we are comparing the strategies like this way. So if you place A1, you place A2, you place A3, you place A4, so what's going to happen? So among all of these strategies, yeah, right, in this first part, the best one is 2. All right. Now, in this other part, the best one here is 3. In this other part, the best one is also 3. So if you look at it, this is A2 here, A3 here, A4 here. There is no dominant strategy for this person, right? Unlike the other one that we did, there is no dominant strategy. So in this case, Tim Toffer does not have a dominant strategy, right? Because look at it, 2 is better among 2 against 1, 2 against 1, 2 against 1, 2 is better. 3, this is 3, summarize properly. 3 against 1 against 2 against 2, 3 is better. 1 against 2 against 3 against 2, 3 is better. So at one point, strategy 4 is better than the rest. At another point, strategy 3 is better. At another point, strategy 2 is better. So the one that we are not even picking anything from it at all is strategy 1. So now, Timtogwe does not have a dominant strategy. Now, Suliyat. For Suliyat, we have 3, 3, 1, 2. We have 2, 3, 2, 1. We have 2, 1, 2, 3. So it's comparing our strategies like this. So for the first one, this is B1, B2, B3. 3 is better than 2. So you pick this one. Then 3 is, anyway, 3, 3. Then, how many do we have? No, have I mixed it up? 3, 2, 2, 3. Okay. Then 1, 2, 2. So like 2, 2, then 2, then 3. Yeah. So there's no strategy of ours that is entirely better, right? So at some point, she prefers strategy 3, at 2 points actually, at this point and this point. But then strategy 2 at this point and this point, then strategy 1 at, so there is no strictly dominant strategy among us. So she has no dominant strategy. Or is there a dominated strategy? I hope you get that. Every other strategies have to be better than it. So 1 equal to 1, 1 is not as good as 2. So here, there is no dominant strategy, there is no dominated strategy. So they all have strengths and weaknesses, in between. Anyway, that being said, now what would now be the Nash equilibrium of this particular game, since it has become something like this? So like let's start working. So here, if A1, if Team Double chooses strategy A1, the way I've been teaching it in my previous classes, he has already chosen A1, right? So he could get any pay of 1, 2, or 1. That's it. But what we should have to do, since Team Toko has chosen strategy A1, so that's now begins to compare payoffs. 3 is better than 2, better than, so she just pick 3 here. Now when Team Toko decides to pick strategy 2, so he has made up his mind, I want to pick strategy 2 now, so he can get any of these payoffs depending on what Suleya does, right? So he has picked strategy A2. What will Suleya do? Suleya can pick 3 or 3, like they are both better than 1, so she can pick this or this. Now here too, Temitope has decided on strategy A3, so now he can get anything. So what will Suleya do? Suleya can pick either 2 or 2. Like she's never going to pick 1. Now A4, right? Temitope has picked A4. So what will Suleya pick? This 2, this is 1, so she will pick 3. Because 3 is better than 1, better than 2. Good. Now we're done with Team Tokwe first picking. Now, when Suliat is now picking her own strategies, let's assume that she was one that was going first. So what will Team Tokwe do? Now, if Suliat has decided to pick B1, like she has decided to pick B1, so she has made up her mind. Whatever comes will now depend on what Team Tokwe is going to do, but she has made up her mind. Can get different kind of payoffs. So what would Team Tokwe do? So Team Tokwe will compare his own two. He's going to pick 2 here. 2 is better than 1, better than 1, better than 1. So we come here B2. So that has picked this one. So what will Temitope pick? Temitope can compare 3, 1, 2, and so Temitope is going to pick 3 because 3 is better than every other one there. Now, if Sulia chooses strategy B3, she has settled her mind that she can get 2 or 1 or 2 or 3. But then what should Temitope now do at that point? Temitope is going to look at it. Okay, 3 is better. 3 is better than 2, better than 1, better than 2. So when we look at it, we have a Nash equilibrium at this point, at this point. So you are now asked that is this a pure Nash equilibrium? It is not. It is not because you're having how many strategies? So Tim Tucker has a Nash equilibrium where he picks strategy two. He also has a Nash equilibrium where he picks strategy three. So like there is no definite strategy that he's picking. Now the same thing for Sulias. If she picks strategy one or strategy three, right? She can, at the end the game ends up, in an equilibrium. So there is no pure equilibrium in this case, unlike the first one that we did. Now, so we found Nash equilibrium. We've figured out that there is no dominant strategy. There's no strictly dominant strategy. There's no strictly dominated strategy, as well. And right, so this is everything about this particular game. So, do they have a best response? No, right? I have told you before that best response is same as dominant strategy. So neither of them has a best response to whatever um either of them, does. So that brings us to the end of this particular game. So you have an assignment to think about. So we have this game on the board between Gloria and Zainab. Gloria has three strategies. She could play top, middle, or bottom. Then Zainab has three strategies as well. She could play left, center, or right. Now these are their respective payoffs. So number one, do either of them have a best response? Identify them if yes. So if you calculate and then you see that any of them has a best response, then identify it. All right, but if they don't have a best response, like no problem. Now, number two, define strictly dominant strategy and identify the strictly dominant strategy of both players. So if both players have a dominant strategy, identify it. If they don't, and then say they don't, right? Now, number three, one of them may have, the other one may not have. Is okay. Number three, calculate the Nash equilibrium. All right, then number four, will either player be motivated after you've done it, after you calculate the Nash equilibrium? So will either player be motivated to use a strategy other than the dominant strategy? Explain. So is there any other question that is here? Okay. So I think that's it. I think that's it. We're fine. So in our next class, we'll be looking at multiple strategies still, but a different method. Mostly look at iteration, how you can get your Nash equilibrium using iteration of dominated strategies. All right. So see you there. Bye and have fun.